Alright, this video is going to deal with demodulation. So what is demodulation? Well, if we have a signal over here and it contains some information, and typically these signals are analog, we feed it into a black box called a demodulator. And we'll abbreviate that as demod. So what comes in is an RF signal that's got data encoded on it. What comes out of here is binary data, typically 1 and 0s. So now I want to go to an analog of two guys talking to each other. So we got a guy over here. And he is speaking to another guy over here. And for simplicity, let's say he is whistling a sine wave, which will be over here. So there's two qualities that for this guy to hear this guy. One is just a sheer amplitude, right? Is that we got to have some amplitude over here, and because his ears are not infinitely sensitive, is that this guy's got to speak loud enough for this guy to hear. And let's assume for the moment that he is. And so this guy is now decoding the information that this guy is transmitting to this guy. Now, in all the universe, things are not as simple as they seem. Is that this guy not only hears what he hears, but he hears the background noise. And as long as this background noise is pretty low, is that this guy can decode and not miss any information that this guy sends. But as this background noise increases, say there's a crowd or something over here making noise, right? So this guy starts to hear the noise, and now he hears signal and noise. And as this noise increases, this guy is starting to miss some of this information. So let's introduce a term, the signal to noise ratio. And that is, you think about the signal and the noise. And of course, radio engineers like to express this ratio in dB. Alright, so if you have a very high signal noise, where there's a lot more signal than noise, this guy doesn't miss any of the information. So let's introduce another term called bit error rate. And we'll abbreviate that as BER. Okay, so I think it's fairly intuitive that as the noise increases, the bit error rate goes down. Now, typically, here's what we design to. Typically, we design to drop only 1 bit in 10 to the 6 bits. So we design the circuits. We want to have enough signal over here so that we only miss 1 bit in every million bits sent. Okay. So in subsequent videos, we told you how to calculate the signal. Now we're going to think about the noise. Okay, and it turns out that noise is the nemesis of all radio engineers. So let's start to think about noise in subsequent videos.